Hi dear students, welcome back to physics online class. In today's class, I am going to explain some more numerical problems on the dual nature of radiation and matter. Problem number 11. A photon of frequency of frequency 1.5 into 10 to the power of 15 hertz. Photon of frequency 1.5 into 10 to the power of 15 hertz is incident on a metal surface. Of work function (1.672 electron volt). Calculate the stopping potential. The stopping potential given H is equal to 6.625 into 10 to the power of minus 34 joule second, are also taken as 6.63 into 10 to the power of minus 34 joule second. Okay, this one is the given question. Question ಏನಿದೆ, a photon of frequency ಕೊಟ್ಟಿದ್ದಾರೆ. photon of frequency ಎಷ್ಟಿದೆ ಇಲ್ಲಿ? frequency denoted symbol new. frequency 1.5 into 10 to the power of 15 hertz ಇದೆ. work function ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? what is the value of a work function here? 1.672 electron volt ಇದೆ. calculate the stopping potential. stopping potential find out ಮಾಡಬೇಕಾಗಿದೆ. write the given values. solution given nu is equal to frequency 1.5 into 10 to the power of 15 hertz. Work function phi naught is equal to 1.672 electron volt. This one is a work function. H value 6.625 into 10 to the power of minus 34 joule second or 6.63 into 10 to the power of minus 34 joule second. Now we have to calculate stopping potential. Before that we have to use E is equal to H nu formula. E is equal to H value 6.625 into 10 to the power of minus 34 and new value 1.5 into 10 to the power of 15. E is equal to, multiply this one, 6.625 into 1.5. 1.5. This one is a 9.93 into 10 to the power of minus 19 joule. Okay, this one convert in terms of electron volt. How to convert electron volt? 93 into 10 to the power of minus 19 divided by 1.6 into 10 to the power of minus 19 electron volt. Therefore, E is equal to 6.211 electron volt. Okay, this one is the energy. The next by photoelectric equation E is equal to phi naught plus kinetic energy. Then kinetic energy is equal to E minus phi naught. What is the value of here E? 6.211 minus phi naught value 1.672. Then kinetic energy is equal to how much? 4.539 electron volt. This one is the kinetic energy. Okay, kinetic energy. But we know that kinetic energy is equal to Vs or V naught, stopping potential. Therefore, Vs or V naught is equal to 4.539 electron volt. This one is the problem number 9 over. Next problem number 10. Okay dear students, next one problem number 12. The threshold wavelength of a photosensitive metal is 662.5 nanometer. Okay, this one is the threshold wavelength. If this metal is irradiated with the radiation of wavelength 331 nanometer, this one is another wavelength. Wavelength first one and wavelength second one. Find the maximum kinetic energy of the photoelectrons if the wavelength of radiation is increased to 496.5 nanometer. Calculate the change in kinetic energy of the photoelectrons. Okay, this one is a very lengthy problem. Carefully listen this one concept. Given values. Okay, what is the given value here? Given lambda naught is equal to how much? 662.5 nanometer. 662.5 nanometer. It means 662.5 into 10 to the power of minus 9 meter. Lambda is equal to how much? 331.3 nanometer. It means 331.3 into 10 to the power of minus 9 meter. H is equal to how much? 6.625 into 10 to the power of minus 34 joules second. C is equal to 3 into 10 to the power of 8 meter per second. We have to calculate change in kinetic energy is equal to question mark. This one is the given data. Now apply the formula. Kinetic energy maximum is equal to h nu minus h nu naught. Kinetic energy maximum is equal to h nu means here c divided by lambda and nu naught means h c divided by lambda naught. Hc, it is a constant outside, common outside, common, and that two are constant values, 1 divided by lambda minus 1 divided by lambda naught. H value 6.625 into 10 to the power of minus 34. C value 3 into 10 to the power of 8. 1 divided by lambda value 331.3 into 10 to the power of minus 9 divided by lambda naught value 662.5 into 10 to the power of minus 9. Then 6.625 into 3 into 10 to the power of minus 19. After simplifying this one, we get 0.151. ಇದರ ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಏನು ಬರುತ್ತೆ ಈ ಒಂದು ಆನ್ಸರ್ ಬರುತ್ತೆ ಆವಾಗ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಎಲ್ಲ ನೀವು ಮಲ್ಟಿಪ್ಲೇಷನ್ ಮಾಡಿದವಾಗ ನಿಮಗೆ ಸಿಗುವ ಆನ್ಸರು 3 × 10⁻⁻19 ಜೌಲ್. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಜೌಲ್. Okay, this one also over. Then next one, lambda 1 is equal to lambda according to question. How much here? 331.3 nanometer. 331.3 into 10⁻⁻9 meter. Lambda 2 is equal to 496.5 nanometer. It means 496.5 into 10⁻⁻9 meter. Also we have change in kinetic energy. Change in kinetic energy means final minus initial. Kinetic energy 2 minus kinetic energy 1 is equal to HC 1 divided by lambda 1 minus 1 divided by lambda 2. Here H value 6.625 into 10⁻⁻34, 3 into 10⁸ into 1 divided by lambda 1 divided by 331.3 into 10⁻⁻9 minus 1 divided by 496.5 into 10⁻⁻9. Kinetic energy final minus kinetic energy initial is equal to 6.625 into 10⁻⁻19 into 3 into 0.101 ಇವೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಇಷ್ಟಾಗುತ್ತೆ. ಅದಾದ್ಮೇಲೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಫೈನಲ್ ಮೈನಸ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇನಿಷಿಯಲ್ ಮೀನ್ ದಟ್ ಈಸ್ ಚೇಂಜ್ ಇನ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಚೇಂಜ್ ಇನ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇಸ್ ಈಕ್ವಲ್ ಟು 2 into 10⁻⁻19 joule. Okay, this one is the change in kinetic energy. ಇದೇನಿದೆ change in kinetic energy in terms of joule. Problem 13. Photoelectrons are emitted from a metal surface when UV light of wavelength lambda is equal to 300 nanometer is incident on it. When negative potential required to stop the emission of photoelectrons is 0.54 volt, calculate energy. And the second one is the maximum kinetic energy, and third one is the work function expressed in terms of electron volt. This one is the given question. ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆ ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂಸ್ ಎಲ್ಲ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದರ ನೋಡ್ಕೊಂಡು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ರಿ. ಲ್ಯಾಂಬ್ಡಾ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಷ್ಟಿದೆ 300 nanometer. ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ 0.54 volt. First one we have to calculate energy is equal to question mark. Using formula E is equal to H into nu. Convert H into nu divided by H is equal to H into nu means C divided by lambda. E is equal to H value 6.63 into 10⁻⁻34. C value 3 into 10⁸8 divided by lambda value 3 into 10⁻⁻7. Then E is equal to how much? 6.63 into 10⁻⁻19 joule. This one is the energy. This one energy converted in terms of electron volt. E is equal to 6.63 into 10⁻⁻19 divided by 1.6 into 10⁻⁻19. Its answer is equal to 4.14 electron volt. This one is the energy. First one over. Then second one. Kinetic energy maximum. Kinetic energy maximum is equal to question mark. Kinetic energy maximum is equal to E into V naught or Vs or EVs. Kinetic energy maximum already they given 0.54 electron volt. Already this one convert in terms of converted in terms of electron volt. And third one, work function is equal to question mark. Using formula, kinetic energy maximum is equal to h nu minus work function. H nu naught is equal to h nu minus kinetic energy maximum. What is the value of h nu here? E value in the place of h nu, E minus kinetic energy maximum in the place of E value. First one answer 4.14 minus this one is a 0.54. Work function answer 3.6 electron volt. This one is the final answer. Okay, dear students, in today's class we solved total 3 problems. You have to practice that all the problems that all are very important for your problem, numerical problem purpose, examination.